Looking for projects for your academics? Need help with your project? Want any pre-built project? Then you are at right place. Welcome to my channel, Project Solutions Hub. Hello everyone, and welcome back to the channel. If you're a B.Tech CSE student looking for a simple yet effective mini project to boost your skills and add to your portfolio, you're in the right place. Today, we're going to walk through a fantastic project, a digital clock and countdown timer using HTML, CSS, and JavaScript. This project is perfect for understanding fundamental web development concepts like real-time updates, user input handling, and dynamic styling. Let's dive straight into the code. This entire project is contained within a single HTML file, making it incredibly easy to set up and run. First, we have our basic HTML boilerplate. Notice the meta viewport tag, which is crucial for making our application responsive across different devices. We've also linked the Tailwind CSS CDN. Tailwind is a utility-first CSS framework that allows us to rapidly build custom designs without writing much custom CSS. Inside the body, we have two main div containers. The first div is for our digital clock. It has a H1 tag for the title digital clock and a div with the ID digital clock. This div is where the current time will be displayed. The second div holds our countdown timer. Similarly, it has a title countdown timer and a div with the ID countdown timer for displaying the remaining time. Below this, we have three input fields, one each for hours input, minutes input, and seconds input. These are of type number and allow the user to set the duration for the countdown. We've also added some UI elements like colons to make the input section visually appealing. Finally, we have three button elements: start button, pause button, and reset button. These will control the countdown timer's functionality. Now, let's look at the styling, primarily handled by Tailwind CSS and a bit of custom CSS. In the style block, the body is styled with a dark background, light text, and uses a flexbox layout to center its content. We've set min height 100 VH to ensure it takes up the full viewport height. The font family is set to Enter, a clean, modern font with a fallback to sans serif. The container class defines the appearance of our clock and timer sections. They have a slightly lighter dark background, rounded corners using border radius 1.5 rem for a modern look, and a subtle box shadow for depth. They are set to width 100% with a max width to ensure they look good on larger screens while adapting to smaller ones. The time display class is for the actual time numbers. It uses a monospace font for consistent digit alignment, a large font size for rem, bold weight, and a vibrant blue color, #63b3ed for visibility. The countdown input class styles are number input fields, giving them a specific width, padding, rounded borders, and colors that blend with the dark theme. For the buttons, we have a base button style that includes padding, rounded corners, bold text, and a transition for smooth hover effects. We then define specific color schemes for primary, green for start, secondary, yellow for pause, and danger, red for reset actions, each with a subtle box shadow to make them pop. Lastly, there's a media query for max width 640 px. This is our responsiveness in action on smaller screens like mobile phones. The font size for time displays, width and font size for input fields, and button padding are reduced to ensure everything fits comfortably and remains usable. Moving on to the JavaScript, which is the brain of our application. First, the digital clock logic. We have a function update digital clock. Inside it, we create a new date object to get the current date and time. We then extract hours, minutes, and seconds using getHours, getMinutes, and getSeconds. Crucially, we use string pad start to 0 to ensure that single-digit numbers like 5 seconds are displayed with a leading 0 as 05, maintaining the consistent SS format. Finally, we update the text content of the digital clock element with the formatted time. To make the clock update in real time, we use setInterval, update digital clock, 1000. This function calls update digital clock every 1000 milliseconds, or every second. We also call update digital clock once immediately after defining it, so the clock is displayed as soon as the page loads, avoiding a 1-second delay. Now for the more involved countdown timer logic. We start by getting references to all our HTML elements, the display div, the 3 input fields, and the 3 control buttons. We declare 3 key variables. Countdown interval. This will hold the set interval ID for our countdown, allowing us to clear it later. Total seconds. This variable will store the total remaining time in seconds. Is paused. A Boolean flag to track whether the timer is currently paused. The format time, seconds function is a helper. It takes a number of seconds and converts it into a SS string, similar to our digital clock, by calculating hours, minutes, and seconds using, and the modulo operator, and then padding them with leading zeros. The update countdown display function simply takes the total seconds and updates the countdown timer display element using format time. It also includes a check. If total seconds drops to 0 or less, it clears the countdown interval, sets the display to 0 hours, 0 minutes, and 0 seconds, and provides a visual cue by temporarily changing the text color to red, then back to blue after a second. This is a user-friendly alternative to alert for indicating the timer has finished. The start countdown function is the core of our timer. First, it checks if is paused. If the timer is not paused, it means we're starting fresh or resuming after a reset. In this case, it reads the values from the hours input, minutes input, and seconds input fields, parses them as integers, defaulting to 0 if empty or invalid, and calculates the total seconds for the countdown. It then checks if total seconds is 0 or less. If so, it updates the display to 0 hours, 0 minutes, and 0 seconds, and exits, preventing a countdown from starting if no time is set. It sets is pause to false and manages the disabled state of the buttons and input fields. Start button is disabled. Pause button and reset button are enabled, and the input fields are disabled to prevent changes while the timer is running. Crucially, clear interval. Countdown interval is called to clear any previous interval, preventing multiple countdowns from running simultaneously. Then, a new set interval is set up. Every second, it decrements total seconds, if greater than 0, and calls update countdown display. When total seconds reaches 0, the interval is cleared, the start button is re-enabled, pause button is disabled, and the input fields are reset to 0, preparing for a new countdown. Finally, update countdown display is called once immediately to show the initial set time. The pause countdown function is straightforward. It simply clears the countdown interval, sets is pause to true, and toggles the disabled state of the start and pause buttons. The reset countdown function completely resets the timer. It clears the interval, sets total seconds back to 0, is paused to false, updates the display to 0 hours, 0 minutes, and 0 seconds, clears the input fields, and resets the button and input field disabled states to their initial configuration. Lastly, we have our event listeners. We attach click event listeners to the start button, pause button, and reset button to call their respective functions when clicked. The initial state for buttons ensures pause and reset are disabled until a countdown is started. We also have change event listeners for the input fields, hours input, minutes input, seconds input. These are important for input validation. They parse the input value, ensure it's a number, not negative, and stays within a sensible range. For example, 0.59 for minutes seconds, and capped at 99 for hours for sanity. This prevents users from entering invalid data. Now that we've dissected the code, let's see how this project looks and functions when you run it in a browser. When you open the HTML file, you'll see 2 distinct sections, beautifully styled with a dark theme and rounded elements. Digital clock. This top section immediately starts displaying the current time, hours, minutes, and seconds, updating every single second, just like a real digital clock. It's clean, legible, and provides instant real-time information. Countdown timer. Below the digital clock is our interactive countdown timer. You'll see 3 input boxes labeled hours, minutes, and seconds. You can directly type in the desired duration into these boxes. For instance, you could enter 0 for hours, 5 for minutes, and 30 for seconds to set a 5-minute and 30-second countdown. Once you've set your time, click the Start button. You'll see the countdown timer display begin to count down, second by second. While the countdown is active, the input fields will become disabled, preventing accidental changes. The Start button will also be disabled, and the pause and reset buttons will become active. If you need to temporarily stop the countdown, simply click the pause button. The timer will freeze at its current remaining time, and the start button will become active again, allowing you to resume from where you left off. To stop the countdown and clear all settings, click the reset button. This will revert the display to 0 hours, 0 minutes, and 0 seconds. Enable the input fields and restore the start button to its initial active state, ready for a new countdown. When the countdown reaches 0, the display will show 0 hours, 0 minutes, and 0 seconds. And for a brief moment, the text will turn red as a visual alert, then return to its normal blue color. Responsiveness. This application is designed to be fully responsive. Try resizing your browser window or opening it on a mobile device. You'll notice that the text sizes, input field widths, and button layouts adjust gracefully to fit smaller screens, ensuring a great user experience on any device. This project is an excellent starting point for understanding how to combine HTML for structure, CSS for presentation, and JavaScript for dynamic, real-time functionality. You can further expand on this by adding sound notifications, a list of preset timers, or even integrating it into a larger web application. I hope this explanation was helpful for your B.Tech CSE mini project. Feel free to leave any questions in the comments below. And don't forget to like this video and subscribe for more project ideas. Happy coding! Thanks for watching. Keep learning with Project Solutions Hub. And don't forget to like, share, and subscribe.